Recording in progress.
There we go. So this information is helpful because if you do need to log on to Zoom, like if you're not feeling well, or somebody like the seniors might be on college visits, or maybe some of you guys might be traveling for sports, maybe you have some downtime, you still want to join class, you can. I'm very comfortable with Zoom. I could do hybrid. Some teachers don't like it. I think math, I think it works pretty well. Or let's say, for example, you can't come during office hours and we have a test like in a couple days and you want to meet on an evening, totally fine. All I just say is that 5 to 7 is kind of off limits. That's when I have dinner with my kids, put the kids down for bed, bath, all that stuff. After 7, 8 o'clock, either I'm watching Netflix or sports, but I could take away from that and help you guys out too. So if you shoot me an email, say, Mr. E, I need help at 8 o'clock at night, not a problem. I'm there for you guys. So, but we have office hours too, after school. This is all just blah, blah, blah. You guys kind of know, just kind of just boilerplate stuff. Textbook. So when Iris asked a question about textbook, it's a good resource to have. I don't think you necessarily need it because I kind of like these notes better and the homework problem sets I give you guys. So don't necessarily need it. If there's stuff in the textbook that I feel might be useful, I can always make copies of it. But don't feel obligated that you have to get a text. If you do get it, leave it at home. It could be a good resource maybe when you're in college or down the road. I don't know. It's your call. I did talk about the grading breakdown. So we're gonna have 3 categories. We're gonna have performance tasks, which is basically homeworks and quizzes, tests, and final exam. I said I'm not collecting homework though. In lieu of collecting homework, for me to make sure that you're staying on top of the material, there'll be homework quizzes. Homework quizzes, however, will be or homework check-ins. They'll be actually at the end of class. So if you feel like, well, I still don't understand homework or I didn't quite do all of it, that's okay. We'll have that discussion at the beginning of class. We'll do some other stuff that will reinforce those topics, and then we'll do it near the end of class. Also, I know that some people work longer or faster than others, so it's probably better to do it at the end of class anyway. And it'll be 3 multiple choice questions. I probably might put in the Schoology platform just so it gives you the grade quickly. And you might have a few that don't go well. Don't worry about it. I will drop the 4 lowest. If it so happens that you ace all of them and dropping actually hurts your grade, then I won't drop them. So I'll make sure there's some equity there at that.
Just homework quizzes?
Just homework quizzes, yes. There'll be normal quizzes too, midway through a unit. That's at my discretion when I feel like we should do one. We probably should just kind of check and see how it's going. Tests, we'll have 4 tests. So as you see with the syllabus right here, nope, that was, oh, that's weird. It says algebra 2. This should say precalculus. But anyway, yeah, there'll be 4 tests. So we have these 4 units here. Retakes, as I said, there'll be 1 retake. There'll be midway through the semester. Once I do post it, like, hey, here's when the retake's going to happen, you have a week to get it done. You have to be outside normal class time. So if you're an ASC student, you take an ASC. If you're not, you can schedule time with me during a free period. Fortunately, I only teach 3 classes, so I have A, E, F, G, all free. You do after school, you can do at lunch, whatever. And I average a 2 test grade. So if test 1 does not go well, you do the retake, great. I average test 1 in the retake. Or if test 2 doesn't go well, then I do that. And the retake will consist of material from both test 1 and 2. And because there's a flow to it, you know, so you still have to know all this stuff. James, go ahead.
So for the retest, it's like the first section will be like test 1, the second section will be like test 2.
I haven't thought that far ahead, but sure, I can design it that way. That's not a problem. There will be a final exam. I won't be here when you guys do your final, so I'll make sure that you guys have all the materials and that your sub is prepared, so your sub is not busy trying to do all that stuff. But more details we share in a couple weeks. I do co-teach this with Mrs. Sasui, so she'll probably take the lead in that. Iris, good.
For tests, are we going to have like reviews?
Yes, absolutely. 100%. Yeah, I'll give you all the finer details. I do that for all tests. Yeah, pedagogically, I feel that should be done. Teaching approach, I do a variety of things. Today's just going to be basically lecture and kind of like interactive work. Sometimes I might just give you guys a video to watch, like here's a video, and then we just talk about the video the next day and do problem sets. It just depends on what we're working on. What to bring to class, obviously, you know, just stay organized, bring the folder, bind whatever works for you. Maybe some like writing, well, you need writing utensils, obviously, but maybe some non-black pens for correction. Definitely the graphing calculator, that's essential. And if you have to Zoom, then of course you're zooming on a device from somewhere else. You guys should know the goals by now. Academic honesty, blah, blah, blah. You guys know that story. If you do have AC accommodations, I do have that list. We could talk offline, like, hey, I have 50%, 100% of the time. This is when I may want to do a test. Just talk to me. I'll work with you on that. Very flexible when you want doing your test. Schoology, that's my responsibility to post up by 4 p.m. I'll make sure I'll do that. Outside tutoring, this is kind of a new section we're adding to our instructional policy. If you do have an outside tutor, that's great. I think that's awesome. I myself actually do work as an outside tutor for other schools. I've been doing it for about 20 years on the peninsula. I firmly believe that if you want tutoring to work for you, if you do have that, make sure I'm in communication with your tutor, because I find that actually that leads to much better results than we're both on the same page. I kind of like, for those who like follow sports, it's kind of like I'm the head coach, your tutor is more like the assistant coach, but we need to be on the same page, right? So that's just something to keep in mind if you do have that resource. But of course, I'm here to help you guys. I am your best resource, so hopefully you wouldn't need a tutor. You could just talk to me. I could help you out. But sometimes I know you need extra support too. And remember, we have the ASC also. We have Homework Club. We have all these resources here. And in typical class structure, the way I envision class going, obviously I walked in a little late. I'll be more punctual. I was making copies, but we'll kind of just check and see how it's going, take attendance, blah, blah, blah. It's, may talk about whatever happened over the weekend or stuff like that. Go over homework questions, that's important. And then really spend the bulk of our time going over the topic at hand. And then if we have some time at the end, like today, I hope you guys don't have homework this weekend. I think it'd be great. We could try to get some homework done in class today. And then at the end, we do a checkout, like a homework quiz. That's not going to happen until Monday, because we haven't done any material yet, right? So by Monday, we'll have our first homework check-in. All right, and then this is what the class is all about. A lot of this is an overlap of Algebra 2, but this stuff right now we're doing, you guys didn't do this in Algebra 2. You guys didn't do trigonometry. You did a little bit of trig and geometry, but very little. So we're going to go really deep with that. The second semester will be more like an overlap of Algebra 2. And the course objectives, I mean, yeah, obviously you want to be a good math student. I think the big one for me personally is to make sure you guys can understand how a lot of these functions behave graphically, algebraically, and numerically, and how all three of those things are intertwined. So like the Star Wars characters, you got to know that intimately. Like, for example, R2-D2, I mean, if you watch Star Wars movies, R2-D2 is very resourceful, also very mischievous. Always C-3PO is always like giving a heart. I know, I'm a big Star Wars nerd. But the point being is that you got to have intimate knowledge of these functions. And that's kind of my hope, is that you go on to calculus knowing this stuff really well. Okay, that is enough of me blabbing about that. So any questions on policies? And this could change. I mean, it's not a static document. It's dynamic. It could change. I'll let you know if anything does change. But for the most part, I mean, we have 4 tests. We have homeworks that I assign, but I don't collect it. We do check-ins in lieu of me collecting and correcting homework. We will have a final. We haven't done fall finals in about 3 years, so that's coming back. So we are going to have a fall final. Okay, let's go through the notes. So let me close this down. And let's look at 4.1. So our plan is to cover all 4 of these pages today. And there's a lot of terminology and I have to fire your way. So it's going to be a lot of me talking, but stop and ask if you have questions. When we do get to, if we do get to the end of this, hopefully with enough time left, here's the homework that you'll do. And I copy this, and it's not too bad. It's pretty short, but you should be able to get this done. Hopefully we'll have a chance. We'll see. Okay, so let's start with angles and their measures. So what is an angle? A few ways you could define it. I would say it's basically 2 rays with a common endpoint. I would define it as that. The initial side will be one of the rays.
Doesn't matter which side.
It will when we do the drawing. It will, yes, it actually will. But initially, will be one of the rays. And actually, let me. So thank you, James, for asking that question. That sits on the positive x-axis. Because you're going to actually draw angles different than you have done in the past. So we're going to actually call this the initial side. The positive x-axis, yes. We're going to call that the initial side. Obviously, where we start. And again, an angle is just two rays, right, with a common endpoint. So see, I got two rays here. Common endpoint. Okay, the terminal side. You think terminal? What do you when you hear the word terminal? And you could be as morbid as you want to be. Dead. Great. If you have terminal illness, it's not good. But also think about the airport terminal. What's beyond the airport terminal? The plane, and that's it. The runway. You go off to your vacation, right? So it's ending, right? So it's going to be another ray where the angle ends. So I could draw it kind of like this and call that the terminal side. And what we'll do also is we'll draw something like this here, showing the direction of the angle. The direction is going to matter. Actually, it's going to matter a lot in this class. I'll get into all those details a little later. And then the vertex is the common endpoint. So right here is the vertex. We call it the vertex. So again, an angle, just two rays with a common endpoint. The initial side, there obviously are two sides, but which one are you going to call initial? I'm going to call the one that's horizontal flat, that sits on the positive x-axis as initial. We're always going to start at angles this way. In this class, will always be true. So the terminal side is where the angle is, right? And we're going to be concerned about the direction the angle's moving. Is it moving counterclockwise or is it moving clockwise? That is going to matter, and we're going to have a way of understanding that down the road. And then the vertex is common endpoint, or the sharp corner right there. Okay, any questions? Okay, now, right below something called standard position. This is where direction matters. Can I clear this? We're okay? Okay, yeah. I'll go and clear it. And again, if I'm going too fast, just let me know. I'll pump the brakes. All right, standard position. So standard position is, and I'll write this as a text box because it's easier. My handwriting's not the greatest. An angle drawn in such a way okay. So it's an angle drawn in such a way where one side sits on the positive x-axis, and we move either clockwise or counterclockwise to the terminal side. So, for example, that's not gonna work. There we go, much better. Okay. Initial side. Let's say my terminal side is right here. Great. So this is initial. This is terminal. And clearly moving counterclockwise. CCW, counterclockwise. But we can also move clockwise too. I could have done this and move clockwise also. So that's what standard positions
So
meant.
you always go from initial to whatever the side is.
Right. And what we're going to start talking about is like actually how to draw this. If I give you like say a certain angle, like say draw from a 100-degree angle. So for example, let's say I told you to draw a 100-degree angle, right? So here's what you're going to do. If I want to draw 100 degrees, tell me when I should stop. Oh, good, thanks. That'd be 100 degrees, right? What if I did this? What if I did that? How many degrees do you think I traveled roughly? about 300 or 290, definitely more than 270, right? Obviously 180 is half a revolution, quarter revolution is 90. So we're going to talk, so what I just drew is standard position. Standard position is basically start on the positive x-axis, move either clockwise or counterclockwise. And by the way, counterclockwise, this is the part that's somewhat counterintuitive, no pun intended, but somewhat counterintuitive. Counterclockwise is considered the positive direction. Clockwise is considered a negative direction. So for example, if I drew this, so, and this is my initial side. So how much have I traveled so far, would you say? 45, but I would say it's negative 45. Because I'm going clockwise. So if you're going the clockwise direction, you state it as a negative angle. If you go counterclockwise, you state it as a positive angle. We're going to talk a lot about that in the next few problems. But that's standard position. So this is kind of laying all the groundwork here. Okay, so now let's talk about stuff from geometry, and then we'll get into other stuff down the road. Okay, a problem with angle measures. So you guys have seen this before. Does anyone know what this symbol is called? It's like a little zero with a line through it. Theta. Good. Yeah. So this is called theta. It's a Greek alphabet. I don't know why that's used. Can tell the history behind that, but just get used to it. We use that letter a lot. My thinking is that because there's so many variables that are used, sometimes we exhaust all the stuff in the English language, so we use the Greek alphabet too, I guess. I don't know. But excuse me. You guys might remember this from back in the day. Okay. So what is that for? Why do we have that? It helps you to determine which trig function goes with what sides, right? So for example, excuse me. Say I put theta right here. Now this side I call opposite. Why am I calling side opposite? Because obviously it's opposite that angle, right? What would I reserve for this side right here? What would I call that? Yeah, good. Because it's the longest side, right? The hypotenuse is always going to be the slanted side of one opposite the right angle. And then what would I reserve for that horizontal side? What would I call that? Because clearly it's adjacent means next to, so that side's next to the angle, so I call it adjacent. So when you have SOHCAHTOA, what it's telling you is that sine theta equals opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse. And tangent theta equals opposite over adjacent. So what does this mean? This means that trig functions are simply a ratio of two sides. Let me write those in text box. It's very important. Any trig function, sine, cos, or tan, is simply a ratio of two sides of a right triangle. The input is an angle in the triangle represented by theta. There you go. So again, any trig function, sine, cosine, tan, it is a function. You guys have learned a lot about functions, right? We talked about like Star Wars, right? Like you guys learn about rational functions, you guys learn about square root functions, you guys learn about linear functions, you guys learn about quadratic, you guys learn about polynomials. Obviously, this semester is going to be dominated by trig. So sine, cosine, tangent, those are functions. So y is going to equal sine or cosine or tangent, right? What is it really telling me? It's just telling me the ratio of two sides. So I said, find me sine at 30 degrees. If I put a 30-degree angle there, that's going to have some length. That's going to have some other length. And just tell me the ratio of those two sides. But it's based upon this mnemonic here, SOHCAHTOA. Sine opposite of hypotenuse, cosine is adjacent for hypotenuse, tangent opposite over adjacent. The input is always going to be an angle within the triangle. So the angle is going to be the input. The output is a ratio of two sides. That's all it ever is. Sine, cosine, tangent is always going to be just a ratio of two sides. This one part is actually really help nail this home. Sine theta is never, actually, let me add to that. Let's change the color, see if we have a contrast. No, that's terrible. Let's do a better color. Here we go. Sine theta or cosine theta.
And for these, will you have to like determine where the theta is and let it give it to you?
We'll give it to you. Yeah. Yeah. No, not that bad at all. It's just a lot of new stuff. Well, I think I could say that what I wrote in blue. Sine theta, cosine theta can never be larger than 1. Think about what sine theta represents. It's opposite of hypotenuse, right? So it's the ratio between two sides of a triangle. What's the longest side of the triangle here? So can the opposite side be bigger than the hypotenuse? No. The reason why I emphasize this is because I know what happens in math. I know sometimes you guys memorize. It's not your fault. You guys have a lot going on in your lives. Sometimes we memorize the process, memorize the solution, right? And then when you work on something like, let's say I ask you to find the sine of something, and then you put like 1.5 as an answer or 2 as an answer. Then I get kind of upset by myself because I didn't teach it properly, probably. But I'm trying to tell you right now that that's impossible. That is totally impossible. So never put that as an answer. You know it can't happen. How can the opposite side be larger than hypotenuse? That's physically impossible, right? Because how a triangle behaves. Same thing with cosine. Cosine is adjacent to hypotenuse. That cannot happen. The hypotenuse will always be the longest side. So you're never going to report a sine or cosine that's larger than 1. Like we said, cosine of some angle is 2.5. That's ludicrous. That cannot happen. So just be mindful about that. Hopefully that will deepen your understanding, enrich your understanding of how sine, cosine, tangent behave. Tangent could be whatever. Tangent is free for all. Because tangent opposite or adjacent, and I could design triangles like this, right? That's a triangle, why not? That could be a size like 30, and that could be 1. Why not? Like that totally could happen. But there are restrictions with the sine and cosine, just so you know. Okay, so I kind of gave you a lot of information. Any questions so far about what I just discussed? And I know it's not quite related to what you see in the fine print, but I just want to make sure I had that discussion with you guys. That you guys understand what is sine, cosine, tangent. Cool. All right. Let's go back to our discussion about degrees. Okay. I'm just trying to think here. I don't quite like how these notes are set up. That's my bad. Let's do this. You guys can just sit back and relax. I'm gonna pull up a whiteboard instead.
Hey-o.
Here we go. Okay. There are filled out notes for this. Even oh, if you want to, sure, yeah. Are you more comfortable doing that right now? Okay. By Monday, you'll be able to do that. Yeah. Okay. All right. So let's come back to this now. Let's go back to a circle. And again, you guys just sit back, relax. You don't have to write anything down. But participant ask questions, right? All right. I know this is a long day. So here I drew a circle and I drew a piece of the circle, right? Let's say that's 2 and 2. And let's say it's 90 degrees. Okay. And say I asked you to find me this length. Okay. How'd you do that? How'd you find the length of what I highlighted in yellow? Any thoughts?
Opposite over.
No, that stuff. None of that stuff. Okay, good. I'm glad. All right. Well, how about this? Do you guys remember circumference?
Pi divided by 4.
Wait. Wait, you say, you're on the right track. What were you saying? Okay, no worries. Okay. Well, so how about circumference? Just going back a couple years or 3 years ago. Well, no. It's just circumference first.
Wait, pi.
2 pi r.
Yeah.
2 pi r, right? That's circumference, right? So the circumference would be 4 pi. So what this would mean is that, let's say you're on a circular track, right? You're on a circular track and you walk all the way around, right? Or so you go out to like, a football field, it's not surface football, but you get the idea, right? Or say you're running a wearable device, like something that tracks your steps, right? How far did I walk? Would be that, right? 2 pi is roughly 3.14, so you do 2 pi times 2 is like 12 point something. However, I want the yellow part. Close.
5.4.
Why by 4, guys?
Because it's a quarter. 4 sides.
It's a quarter. How many degrees is a whole circle?
360.
Right. Whole circle. So this is proportional reasoning, which you guys are totally capable of doing. You guys just demonstrated that right now. Whole circle is 360 degrees. This right here is 1/4 of the circle. Obviously, because you have 90 degrees, that's defining it. So 90 over 360 we know is 1/4. So how do I find the arc length? Let me write that more nicely. How do I find the arc length? The arc length is what's highlighted in yellow. 1/4 times 4 pi. 4 pi. So that's just a review of geometry, right? So does that make sense? Proportionally, what's happening? Hope that's intuitive, right? So again, if you have a circle like this, the circumference is 4 pi. That's a quarter, right? Because it's divided by 90 degrees. So it's 1/4. What if I change this up just a little bit? What if I had this? It's the beauty about zooms, I can annotate real easily. What if I had 60 degrees? And that's 2 and 2. So what fractions is covered here now? 1/6, 6 over 3/6, exactly. So then instead of 1/4, I'd multiply by, come on, here we go.
So you take the circumference and then multiply by
The fraction that that's defined by the central angle. That's going to be kind of key. So 1/6 times 4 pi, which would be 2 pi over 3. And that's, why am I doing yellow? Here we go. 1/6, that'd be 2 pi over 3. Okay, now, here's the part I really want to get to. Okay, another circle. That's 2 and 2. Now, could my arc,
What if it's like 1/5? Something like, does it matter?
doesn't matter.
You just have to find like because what if it's not exactly divisible by 360?
Oh, then you just leave it as a unsimplified, just as a fraction. Whatever, like say it's 1/7 of the circle and divide by 7, right? Now, could this arc equal, or could this arc have a length of 2? Could this arc have the same? Actually, it could. Why not? Yeah. No, we're not doing triangles all. Just circles.
Because it's less than pi.
I mean, could this have a length of 2? Sure. Why not?
But how though? If it's the same as like you have the.
Well, I mean, this could be really tiny. This could be like 0.1 of an inch. This could be. There's no reason why this can't be the same. So the bottom line is this: that generally speaking, you could have something like this here. You could have an arc. Let me draw this one more time. If that's R and R, that could be R also.
And it all has to be the same length?
Well, when this happens, this is the big thing I want to talk about. When this happens, I'll do as a text box. When the arc of a circle is equivalent to the radius, the angle formed by the arc is, and this is a big thing I'm saying here. It's called 1 radian. Radian is another unit of measure for angles. Like for example, distance. We could do miles, or you do kilometers. Weight, we do pounds, we do kilograms, right? Volume, I can do gallons, I can do liters. Same thing with angles. I could do degrees, which we're more comfortable with, or something called a radian. A radian is defined as that. That's considered 1 radian. Okay, so 1 radian is when that happens. Now, what if you want to find what that actual angle is? I'll tell you right now, it's about 57.3 degrees. So let's compare this to a degree. So now this is the big question. The big question, how does radian relate to degrees? That's going to be the kind of the whole essence of what we're doing today. How does the radian relate to degrees? Well, let's back up a little bit. How many degrees is the whole circle again? Right? And what's circumference? 2 pi r. And right now, what's the length of my arc? R. And what is this angle here? We're saying it's 1 radian. So what I'm doing right now, just so you know, let me back up a little bit. Hold on.
Is radian only used for finding the angle of an arc?
No, it's just for any angle. Any angle. You could use crap. Well, I messed up here. Give me 1 sec. Here we go. There we go. Okay. So 360 degrees is the circumference. 1 radian is this angle here, and what arc would have the arc? If you cross multiply, here's what's going to happen. You're going to have, I'll erase this because we don't need it right now. If I cross multiply 360 degrees times r will equal 1 radian times 2 pi r. What happens to the r's? They cancel. 360 degrees, 2 pi radians. So 2 pi radians is a full circle. We know this because this has been part of our culture. You know, if you are like a snowboarder, or skier, or whatever, or you just like skateboarding, I don't know, or just you just know your rotations. 360 is a full revolution, right? 2 pi radians is also a full revolution. And the reason why that's true is because, is this a fair comparison? Can I say this circumference is 360 degrees? This circumference is full circle, 360 full circle. Our arc here was r, and I told you that 1 radian is defined as when the arc length is equal to the radius. That's 1 radian. So these are equivalent. These are proportional. Since these are proportional, if I were to cross multiply these and drop off the r's, 360 equals 2 pi radians. So 2 pi radians equals 360 degrees. That is a key conversion for this class. 360 degrees equals 2 pi radians. I don't expect you guys to fully grasp this just yet. It's a novel concept. I get it. It will get reinforced over the next few weeks. I'm sure you probably wind up memorizing it. I get it. But I feel like to do this justice, I have to have that deep discussion of what is a radian. So a radian is an angle measure in such a way where if you drew a circle and the arc equal the radius, that central angle is called 1 radian. Because arc is r and 1 radian is measure, that proportion, that ratio is the same as this over here. Those are the same. If I cross multiply, I wind up getting this. Or I could simplify it. I could say this too. What if I divide both sides by 2? Fine, go ahead. Totally could do that. You do the both sides, fair treatment. So we also say that too. 180 degrees is pi radians. Okay, so that actually helps us set the tone for the next few pages, because this is a very important thing we're talking about. All right, so let's go back to the notes. Let me share my screen again. Okay, here we go. I'm going to jump around just a little bit. Actually, Yeah, let me jump around a little bit. Let's go down. Let's go down here. Let's go to the bottom of page 2. I know, sorry, I'm skipping around. Let's go to the bottom of page 2. So again, that's R, 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 and that's theta. Theta equals 1 radian on the arc length equals the radius. Okay. Oh, when arc length equals the radius. When arc length equals the radius. So theta equals 1 radian when the arc length equals the radius. And that's what I have. Circle, have radius, theta, in the middle, arcs are. When you convert, what you do, so pi radians equals 180 degrees. Okay. So when you convert, I'll give you some examples. Or
90 degrees equals pi over 180.
equals 90 times pi over 180. 90 over 180 becomes pi over 2. Or what if I did the other way around? What if I had like pi over 2? They get 90 degrees.
Wait, it's pi over 2.
So this is yeah, like this is assuming theta equals pi over 2. Where here we assume theta equals 90 degrees. So if I told you theta was 90 degrees, and as you convert that to radians, you do this. If I told you theta is pi over 2, and I told you convert it to degrees, you do this. You multiply by 1/8 over pi if you're given radians.
Does that say negative 90 degrees?
It's 90. My apologies. Let me erase that. So happens when you run out of space. So yeah, so that makes sense, hopefully. Any questions? All right. So this is the part I think will help reinforce it. We're going to fill out this table. Then we're going to talk about some other thing called coterminal angles. Then I'll do some conversions, and then you guys can start the homework. All right. So let's talk about this table here. All right. So I know this is pi. This is 2 pi. Because I told you that already. And that's going to be 0, by the way. Okay, so 360 degrees is 2 pi radians. Think of it. Full circle 360. Or we just did that. I'll run the board again. Like this, right? 360 degrees is 1 full circle, right? 1 full circle is 2 pi r. Okay. So if you do a ratio, and then 1 radian has arc length of r, right? So you can say 1 radian of r. If you cross multiply, again, I did this already, if you cross multiply, what happens? 2 pi r times 1 radian. R is dropped off. 360 degrees equals 2 pi radians. So 360 degrees, 2 pi radians. It's kind of like 12 inches to a foot, right? 60 seconds in a minute. Same thing. It's the same kind of thing. And if I break this down. What if I took half of this? Or take half of this, right? And of course, if you have no angle, if you have no degrees, you got no radius, right? So hopefully those three make sense so far. Now use proportional reasoning. Fill out this table. Let's look at 30. Actually, let's look at 90. 90 is what fraction of 180? So I better put pi over 2 here. All right. 45. 45 is what fraction of 90? What's half of a half? Pi over 4. So you don't really need to use formulas. If you just understand it, you're going to be fine. 60. 60 is what fraction of 180? Third. Perfect. Pi over 3. 30 is what fraction of 60? Close. Pi over 6. Good. Okay. Now let's kind of go in the reverse. 120. What do you multiply to 60 to get to 120? 2 pi over 3. I think you guys are starting to get this. 2 pi over 3, right? Okay. Question so far, how I got this. Does that make sense? What I'm going to do is I'm comparing these degrees to one of the larger angles, right? 60 is 1/3 of pi. Now, if you so desire, you could have done this also. If you so desire, you could have done this, 60 times pi over 180, if you want, and you get 60 pi over 180, which reduces to pi over 3. If you want, you can do that. I think that's very cumbersome. I would much prefer to really know this and just apply the proper fraction to get the rate. Okay, let's look at 135. What do you think 135 is going to be? Well, how's it compared to 45? 3. Okay, so what are you going to say? What are you going to put here? 3, 5, 4. Perfect. Thank you. Nice work.
Sorry, how did that?
How did that happen?
Yes.
Let's back up. Okay, so we got to compare these two numbers, right?
45. Yes.
So what would you multiply to 45 to get to 135? Or what's 135 divided by 45? I know it's not an easy calculation, but V3, right?
Okay. I didn't know it was the equivalent.
Yeah, totally. That's exactly what we're doing.
So then it'd be 3 pi and take the number and 4.
You're multiplying the fraction by 3. 150. We get to know 150. Good. Getting it. Great. 5, 5, or 6. Okay, let's keep this train moving. 210. Do you see a multiple 210 somewhere? Sorry, do you see a factor of 210? Like what about 30?
Yeah. 30, right.
Okay, 30 goes into 210 how many times? 7, 5, or 6. The ones that end in 5 are a little funky. What do you multiply to 45? 45 goes into 225 how many times?
6 times.
5 times. Okay. I think I'm gonna let you guys fill out the route. I'll give you guys a minute. Fill out the route, see what you guys got. I think you guys get this now. This is the way I teach. I don't teach by memorization, I teach by understanding.
Wait, this is so. I think so. 2 times it's 30 going
Yes.
Do we have something for 240? Yes, over 240. Good.
4 pi over 3.
Well, 270.
3 pi over 2.
Good.
Yeah,
We're rocking now. 300.
10 pi
Which reduces to 5 pi over 3. You can do 10 pi over 6.
Fancy.
But let's reduce, right? Okay. Let's make that life simple. 315.
I didn't get that yet.
Okay. It's a little tricky. 45 does go into 315.
6 times.
More. 7 times. A little more. And the last 3 does should be an easier one. 11 pi over 6. Great. My expectation is that by the time you guys finish this class at the end of the semester, that you know these angles really well. And also, we are going to do sine, cosine, tangent of all those angles that we wrote. We're going to, trust me, you're going to do it, and you're going to be great at it. but we're laying the foundation. We're laying down all the bricks. We're gonna build this beautiful house. Generally speaking, it's just gonna be if you have X degrees, it's X over 180. Generally speaking, that's generally what's happening. So. Okay, that was great. You guys did very well there. All right, now co-terminal angles. Okay, let's break down the words. I'm gonna get a highlighter out here. Co and terminal. Okay, so we know co usually means same, like co-captains on a football team, or co-captains on an airplane, or co-pilot, or whatever. Terminal meaning ending, right? So these are two angles. Two angles that end in the same place or share a terminal side.
In the terminal side, the side that's in the negative.
No, just anywhere.
Anywhere, and then it can be in the positive, but if you go
could be.
clockwise, it's positive. If you go.
So let's do some of the to clear out your question. To clear up your question, just give me a moment, because I'll clear. I know where you're getting at. But let me erase the board too.
Thank you.
Yeah. So.
Sorry.
Yeah, go ahead now. Yeah.
Wait,
So co-terminal angles are angles that end in the same place. So let's draw one of these examples down below, and then I'll draw co-terminal angles, and this should hopefully make sense. Okay. Let me move the screen just a tad, and let me shift this up.
So are we on number 2?
Example 2, yes. All right, before we draw this, you have to do two things. Actually, I guess, well, two things. Sketch it in standard position, and then get two co-terminal angles. One positive, one negative, okay? Pi over 3. According to your table, what was that in degrees?
60.
Okay, great. So I'm going to draw a 60-degree angle right now. Tell me when I should stop. Okay, I'm with you on that. Okay, so that right there is standard position. Oh, and by the way, I need to emphasize this again. If angle is positive, if theta is positive, counterclockwise direction. Okay. If theta is positive, do the counterclockwise direction. Okay.
So if but if
Go ahead, James.
We're all on one side, then it's standard.
No, standard position is just going back to what we did in the beginning of the first page of notes.
Okay.
Standard position is just you start on the positive x-axis and you just draw whatever angle you see.
Okay.
That's all.
Is standard position the only position possible?
No, because we're going to draw co-terminal angles.
Okay.
So now here's the part where I really need you guys to focus. What if I did this? Okay, I drew this little spiral here.
Spiral.
Kind of, yeah. So here's the deal. How far did I travel? So I traveled a full circle, didn't I?
Yeah.
And I traveled a little more. How much more did I travel?
60 degrees.
Like 380.
I did 360. 420.
Whoa.
About 420. Exactly. So that's 420 degrees.
But did you start in the center?
No, I started on the positive x-axis again. So co-terminal angles are angles that end in the same place. So 60 and 420 are co-terminal. 60 and 420 are co-terminal. I could also done this.
Did you loop it 2 times?
I could loop it as many times as I want. Infinite times. I could have done this too. What if I did this? This part's a little mind-bending. If but I think you guys can handle it. Okay.
Um,
What if I did that? Good. Boom. Wow, you guys are dancing much faster than my other class in years past. It's amazing. This is incredible. Good work, guys. So negative 300 degrees. Why is it negative 300? Because did I do a full revolution in the other direction? No. I almost did, but I stopped short by how much? By 60. And because it's clockwise, clockwise is going to be a negative direction. Counterclockwise, pause. I know somewhat counterintuitive. Clockwise is negative. I know. I didn't make up these rules. But if it's negative, you go clockwise direction. It's negative. Okay. So negative 300. Negative 300 degrees. Negative. Let's try it again. Yes. Our co-terminal was 60 degrees. There we go. Okay, so part of the homework's gonna be like this, okay? Now, let's do these next two here. Negative 3 pi over 4. Yeah, I'll go back up, sorry. No worries, we're good. Might be a little hard to read, but yeah, they're co-terminal 60 degrees.
So negative 135.
Yeah, yeah. If you were to convert this, in the interest of time, when does class finish?
110.
1:10. Okay, why don't you guys start the homework really soon? Okay, I think I'm almost done here. Yeah, I know. I underestimate how long this would take, but it's good. You guys are learning, you guys are getting it, so that matters more than anything. These pi's cancel.
135.
Yeah, it's negative 135. Exactly. So you're gonna do this. So James, you're asking what standard position? That's standard position. Well, I just do a standard position. That's the general rule for converting. So I did that in the page 2. That's I believe so. Remember, 2 pi radians is 360 degrees. So pi radians are 80 degrees. So whenever I want to convert, I either multiply by pi over 1/8 or 1/8 over pi, depending on what I have. So that's what I did over here. But also we do see 3 pi over 4 in the table above. We saw 135, but it's negative, so it's negative 135. But if you wanted a more universal approach, that works too. Now, coterminal. You guys tell me what's happening here. Let's say I do this. Give me the angle that blue. Nope. More.
No, it's 135 minus 3.
It's more than 180, guys. It's first of all, I'm going counterclockwise, so it's positive.
Wait, so you're adding 2.
You got it, Owen.
25.
Good work. 225. Good work. 225 degrees. Why is that 225? Because I traveled after revolution plus an extra 45. That's negative. The black is negative 135, just so you know. The black is negative 135. Okay, what if I did this? What if I did this? What if I went clockwise again? I'll look at your question for that. When you go this, I went around in the clockwise direction, so it's negative.
Yeah.
I went around negative 360, and then how much more? Okay. So what do you guys think? Negative 360 plus negative. Got it. Negative 495 degrees, exactly. Yep. Okay, good. Let me see what else we got here. Okay, just a little more, just to wrap up. I think you guys are getting it. So I'm going to move on to the bottom here. Okay. So let's go to the bottom. To me, this was kind of the litmus test. Make sure you guys are really getting it, and then I'll give you guys the homework. Okay. All right. 750. All right. All right. So so first of all, is this positive or negative? Positive. So you go counterclockwise. Okay. We're going to start here. We'll go counterclockwise. Tell me when I should stop.
Stop.
Okay, good. Good. Excellent. Excellent. Really? Totally. Why? Because
What's a full circle? So 360, if I go around a second time, then how far am I travel? 720. And I have to do 750. How much more do I have left over? 30 more. 30. Okay, so that's 360, that's 720, go a little more.
so it's pretty obvious now. I know what's going to be coterminal with that. What do you think is going to be coterminal with that? 30 degrees, totally.
Why would it be?
Because 30 ends in the same place.
365.
It ends in the same place.
So it's not.
So
Why is it step less? Why is it plus?
so first of all, we drew 750. Let's back a little bit. So I drew 750, which was 2 revolutions plus an extra 30 degrees. Then the question, because what's 720 plus 30? 750. I'm at the bottom of.
Oh,
You rotate around one.
Rotate again. How much more do you have left to get to 750?
I don't know.
No worries. That's why we ask questions. So 30 degrees is coterminal. Another thing you could do too, by the way, if you guys want, just keep subtracting 360. If you don't want to draw, you can do that too. Every time you subtract 360, do you get back to the same place? Yeah. Every time you add 360, do you get back to the same place? Yeah, totally. So 30 degrees is coterminal. And that's what they were asking you to do there. Find a positive angle. Let's do one more, and then we'll stop there. Okay, let's do a negative one. Let's do this one right here. You just snort. That's hilarious. Okay, sorry. Okay, awesome, great. All right. Yeah, it's not preschool. Let's okay. Okay.
Let's do part C. Okay. So sometimes these are going to be a little complicated, right? So this is going to be a little complicated. So that one was kind of easy. Picture that one you don't still not do. You get a stool. I'm saying the radius. What I would do for you guys, convert the radians to degrees. By the way, let me mention also. If you don't see a degree symbol, you have to assume radians. So I don't see degree symbol for DSV. You better assume radians. Just because it's applied, it's not enough to its radius. If you don't see the degree symbol, you see radius. I will remind you this often. So anyway, kind of a one-lane reply, right? Price cancel. If you were to do the math, use a calculator to remind you, but I know 6 is 180 30 times. I know 7 times 30, 510. Just trust me, I know this.
So negative 510, right?
Okay.
So after I convert it, let's draw. All right, you gotta go clockwise. Negative angle, you gotta go clockwise. Okay. Tell me when I should stop. Negative 510.
I think a little bit more. A little bit.
Okay, good. All right. Good. Okay.
negative 360 plus a little more to get to -5. So you gotta do a little bit of mental math there too. Take away 360 from 510, that's 150. So that's
150 degrees. So if I want to be coterminal and want a positive angle, what do you think that's going to be the blue? What do you guys think?
130.
180.
it's more than 180. I've done
Oh,
one half
okay.
revolution.
210.
210. Thank you, Iris.
You're welcome.
210. 210 degrees.
Oh.
Cool.
Good. Great lesson today. All right, so the homework's right here. I'm actually gonna. So, yeah.
Any homes?
Again, this packet is a homework for the entire first unit. The other packet has another for the entire first unit.
Yeah, like my
That'll be a song. I'll not do it for.
I just want
Okay, so you guys are gonna do 1 through 5.
Okay.
1 through 5 is your homework. Sorry, I thought we were gonna get it done today, but yeah, I underestimated. You know, I'm on 3 months, so still pretty up pace. So anyway, this will be.
I'm not collecting this, but I will do a homework check-in on Monday on this stuff. Okay. I will post a Schoology. It'll be 1 through 5. Okay. 1 through 5, 4.1. I'll post the Schoology later today. We got 5 minutes. You guys can just hang out and relax. We have 10-minute passing period. Is that right now? Yeah. Okay. I think so. You know, it does help if you're a teacher. You gotta make photocopies in between classes. That kind of helps.
Our teachers really screwed it down. Some of them last year, like,
About tardies.
yeah, no, like, not like. So remember last year, like, I had third floor man and I had the second floor.
I had that last year too.
Like, our teachers still like.
I think with 10-minute passing periods, we'll probably be a little more rigid. I mean, you should get the class in time.
Like, I don't think, like, unless you're like really.
Yeah, I never was, but I would say if it's the first class of the day and you show up 20 minutes late, you're late. Yeah, it's like, I mean, you have to have an excuse then. 1 through 5, yeah. Yeah.
Oh, we're doing a group thing. Oh man, I like to. Whoa. Whoa. Yeah.
Whoa. Whoa, okay.
Whoa. You know, it might be stepping. Yeah, no, you definitely are. You definitely true like that. Yeah.
This is the
So. It's so untrue, it's true.